We solved the previous question. So we're also going to do another example together. Then after which, then you guys are going to do some questions on your own. So the question is saying that, so if we have the expression, so if the expression, which is a polynomial, which is x to the power 3, then we have plus px square plus qx plus r. So if this is the expression that we have, and we are told that it gives the same remainders, so gives same remainders. So that is the expression that we have. And we've been told that this gives same remainders when divided by, also let's say by x plus 1, when divided by x plus 1 or x minus 2. That is what we've been given. Then the question is saying that show, so that's a full stop, so let's put a full stop. So show that p plus q is equal to negative 3. That's what we've been given. So that is the first part of the question. Then the second part of the question is saying that if the remainder, so if the remainder is 4. So if the remainder is 4, when the expression, it's the same expression that we are talking about, is now divided by x minus 1. So this time we now have x minus 1. So what is it that they want us to do? From here they now want us to find the value of r. That is the second question that we have. Then we're also going to write the third equation, that which we've been asked. And the third one is saying that if also the remainder, is negative 60, when the expression is divided by, so when the expression is divided by, let's say, x plus 3, find the value of p and q. So find the value of p and q. Okay, so those are the questions that which we've been given. They are only 3 and they are simple. They are simple questions that which we've been given. So from what we've been asked, the first question, so let us write our solution from here for the first one. So this is what we've been given. We are told that this expression that we have is being divided by this and so by this and this, and yet the remainder is the same. So what does it imply? So it simply implies that this expression that we have, f of x, when we have this, when we put the value of x to be negative 1 and when we put the value of x to be negative 2, their remainders will not change. So it simply means that we can actually equate the two equations together. So this simply means that we have this, which is x to the power 3 plus px to the power 2 plus qx plus r. So when we substitute, then the other side we have x minus x plus 1 and x minus 2, which simply means x is equal to negative 1 and x is equal to positive 2. So here we're not going to substitute the value of x. So here we have negative 1 raised to the power 3 plus p multiplied by negative 1 to the power 2 plus q negative 1 plus r. Now we're going to equate it to the other side because they are the same, but we're now going to substitute the value of x to be 2. So this is now going to be 2 to the power 3 plus p multiplied by 2 to the power 2 plus q. We have a 2 plus r. That is what we have, which is perfect. So from what we have, it simply means that negative 1 raised to the power 3, this will still be minus 1 plus p minus q plus r, which is equal to 2 to the power 3. This gives us 8 plus 4p plus 2q plus r. Looking at what we have, we can now collect like terms. And when we collect like terms, this is now going to be p minus q plus r minus 4p minus 2q minus r, which is equal to 8. Now the negative 1, when it goes to the other side, it's now going to be plus 1. So looking at this, we have this and this, which is going to give us a 0. Then we have a 4p as well as the other one which we have out. Then we have p minus 4p, so this gives us minus 3p. Then negative q minus 2q, this also gives us minus 3q being equal to this, and this gives us 9. So from here we can now factor out negative 3, which will be minus 3p plus q equal to 9. And this over negative 3 over negative 3. This and this cancels, and we are going to have p plus q equal to negative 3. And from this point, we can now conclude that therefore, so p plus q equal to negative 3. So this, therefore, this has been shown. So here we're just showing. So it's as simple as it looks. So we're done with that part, and we'll go to the second part of the question. So now that we have that on the board, so we're now going to solve the second part of the question. So I'm going to wrap. Okay, I think this part can be enough, unless it's not going to be enough. So we're going to solve the second part. And from the second part, we've been told that if the remainder is 4 when the expression is divided by x minus 1. So which expression are we talking about? So this is what we're talking about, f of x being equated to x to the power 3 plus px to the power 2 plus qx plus r. And we've been told that this is being divided by x minus 1, which simply means that this x is equal to positive 1. And we are told that this one actually has a remainder of 4, which simply means that whatever that we have, this will now be 1 to the power 3 plus p multiplied by 1 to the power 2 plus q multiplied by 1 plus r, which is this. Then this is equal to 4. Yeah, because we've been asked to find the actual r, which is here. So from what we have here, this simply means that this will be 1 plus p plus q plus r equal to 4. and this one can cross the equal sign. So this will be P plus Q plus R equal to 4 minus 1, which will now be 3. But we know that, so let me wrap the other side so that you can write it properly on the other side. So from what we have here, we know, that P plus Q is equal to negative 3, hence we substitute. Okay, so we have this, which is P plus Q plus R equal to 3, and we've been told that P plus Q is negative 3, which will be minus 3 plus R equal to 3. Then R is equal to 3 plus 3, R is equal to 6. So from here, we've also found the value of this R, which is 6. So we've done a good job, and yeah, we'll still wrap this part so that we can use it to find the values of P and Q. Okay, so that is perfect. So I'll wrap this part. Okay, so from what we've been given, the same function which we are talking about, which is f of x being equal to x to the power 3 plus px to the power 2 plus qx plus r. But this time we've been told that this function is now divided by x plus 3, which simply means that x is equal to negative 3. That is what we have. And we've been told that this has the remainder of negative 60, which is here. Okay, so what we're going to do is this. So here we are now going to substitute with negative 3, which will be minus 3 raised to the power 3 plus p minus 3 raised to the power 2 plus q multiplied by negative 3 plus r equal to negative 60. That is what we are talking about. And negative 3 raised to the power 3 gives us minus 27 plus this and this gives us 9p minus 3q plus r equal to negative 60. But we know that, but r is equal to 6. We just found the value of r from the other side. So when we see r, we're not going to substitute with 6. So we have negative 27 plus 9p minus 3q plus 6 equal to negative 60. So this is what we have. So from what we have, it simply means that we can even collect this, and this will give us negative 21. So from here, let me wrap this part. Okay, so I'm only going to wrap it up to that part. So from what we have, this and this gives us negative 21. So, and negative 21 has to cross to the other side. So this would be 9p minus 3q, okay, minus 3q being equal to 60 plus 27 minus 6. So that is what we have. So from what we have this side, when we do the calculation very well, this is now going to give us minus 39. Then this side we have 9p minus 3q. Then from here we can see that it's something that is common. So we can even do this and multiply throughout by 1/3. So we can say this side by 1 over 3, then this side by 1 over 3. Then when we do that, this is just the same as 9 over 3, which will give us 3p minus 3 over 3 gives us 1 minus q being equal to 3 into 39. So 3 and 3, this gives us 1. This and this gives us 3, which will be minus 13. So when we look at this, we'll consider this to be our second equation. Then we're going to solve this one which we have and the previous one which we had, which we knew, which we had to show in the first place, which was p plus q being equal to negative 3. Okay, perfect. So I think we still have space here. Yeah. So we write solving equation 1 and 2 simultaneously. Okay, so solving them simultaneously, we're now going to have p plus q equal to negative 3, then we have 3p minus q being equal to minus 13. So from here, we can even add them. So that when we add this, we are now going to have 4p, this will give us 0, which will now be minus 16. Then from here, we can divide by 4 and divide by 4. And 4 into, because this and this gives us 16, negative 16. Then 4 into 16, that gives us negative 4. So p is equal to negative 4. So therefore, okay, so we'll not conclude for now. But let us find the value of q. So I'll wrap this part. Then we can pick any of the equations, which is p plus q equal to negative 3. But we found the value of p to be negative 4. So we'll substitute the value of, substitute the value of p. So when you substitute the value of p in this equation, this will now be minus 4 plus q equal to negative 3, which gives us q being equal to minus 3 plus 4, which is 1. So from here we can conclude, therefore, q is equal to 1 and p is equal to negative 4. And we are done with this. So now that we've done this together, you guys also have to try out the questions and see if you have understood. So I'll write the questions for you so that you can also indulge your creativity. Okay, perfect. So they are no longer examples, but this will now be a task. Okay, perfect. So from the task that we have, we'll say so the polynomial x to the power 3 plus ax to the power 2 plus bx minus 1 is divided by, so this is divided by x minus 2 and x plus 1. So it's been divided by 2 things. So from here we are told that the remainders, so the remainders are 7 and 4. These are the remainders that we have. Find the values of A and B. Okay, so that's the first question that we have. Then we'll write another question. this number 1, then we call this number 2. So the remainders when px to the power 3 plus qx to the power 2 plus 4x minus 2. Okay, so the remainders that we have here, so the remainders when this is divided, so when this is divided by x minus 1 and x plus 2 are equal. That's what we've been told, that the remainders are equal. So show that. So I now want you to show that 3p minus q is equal to 4. And after you show me this, so show that this is equal to this. So if also the remainder is negative 18. It's the same question. If also the remainder is negative 18, when the polynomial is divided by x minus 2. Be aware, in the first place we have x plus 2, but here we have x minus 2. Find the values of a and b. That's all. These are the only questions that we have. Then when we meet again, we'll pick it up from here and look at other things. So for today we are going to end here, and tomorrow when we meet we are going to continue with factor theorem, also look at synthetic division as well as long division. So for today, have a good day. We'll meet again tomorrow. Thank you.